All right, welcome to chapter 11 of the Exercise and Sports Sciences and Sports Med and Fitness Technologies Research Methods course. Let me share the screen and we will start. All right, so we're talking about dating this chapter. Not really. We are looking at finding relationships amongst variables, though. So some not really. Okay. So understanding correlation, a quantitative measure of relationship among two or more variables. So do they change together in a predictable way? All right, so it doesn't mean that all things are going in the same direction, but so for instance, if I lift weights, I should get stronger. So those two things should go up together, right? So the more I lift, the more I spend time lifting and dedicating myself to doing that, I should see strength gains. I may also see increases in muscle mass. I may see a negative correlation in the fact that I may lose body fat, right? So as I exercise more, I might decrease the amount of body fat I have, right? So again, there's a relationship, not always positive. Sometimes they're negative, but you see them work hand in hand, okay? And do the variables change together in a predictable way, right? So again, a positive correlation, as variable 1 increases, variable 2 will increase. So it's showing you here that as the distance traveled in 6-minute run, so the further folks go, the higher their VO2 max, right? So as the VO2 max increases, distance traveled on 6-minute run increases, right? So the XY graph is a scatter plot, but you can see a line developing across that. Okay? Negative correlation. The faster the time, or the faster the times on a 1-mile run, the higher the VO2 max, right? So those who can run their miles quicker have a higher VO2 max than those who run it slower, okay? Strength of the correlation ranges from 0 to 1. So 0 means there's no relationship at all. A 1 or a -1, because you're either positive or, there's either a positive or negative correlation, is a perfect relationship. So that's what you'd like to see. That's not normally what we find statistically, right? But the higher you get, so if you get like a 0.9 or 0.95, I mean, those are great. Okay. So again, the way that would play out would be if you look at A, even though there's a lot of scatter plots towards the bottom of that, you can see how they're grouped well together close to the line. Okay. If you look at the C example on the right, you can see that they're a little bit scattered from the line that develops based on the statistics, right? So again, there's a relationship, but it's not very strong, right? So you guys can check the understandings. So calculating correlation, right? So you guys have heard me in some of my examples, say, well, what's the R value? What's the P's, what's the R's, so on and so forth, right? So Pearson's product moment correlation coefficient is what we call an R value, right? You'll see these in statistics. You'll see a lowercase r, right? Can be easily using statistical programs or a spreadsheet. Every word that doesn't sound can be easily used in statistical programs or a spreadsheet. All right. So is there a real relationship between the variables? So again, the actual R is, if the actual R is greater than your critical R, then the correlation is significant. If the actual R is less than the critical R, then the correlation is not significant. In addition, p-values can be compared to the priority alpha levels, right? So, if the R is 0.4 versus a 0.95, both can be significant as long as the P is less than 0.05, but one is also stronger than the other, right? So the 0.95 is much stronger than the 0.40. But again, if your alpha, if you set your alpha level, and so your P level comes in less than 0.05, then you may not have a strong relationship with the 0.40, but it is statistically significant. Okay. Coefficient of determination, so R squared, the amount of the variance in one variable explained by the variance in the other variable. So higher values indicate stronger relationships. Okay. So again, if you have a 0.8 and above, or an R squared of a 0.64 and above, these are very strong. 0.6 to 0.8 are strong. 0.35 to 0.64, R squared is strong. You see as they go lower and lower, you go from moderately to very weak, right? So you've got all the numbers there. So when you're doing your statistics, if your R value comes in, or your R squared value comes in, you can see where it lies, right? So again, I was looking for a meaningful relationship, right? I told you, it's all about dating in this chapter. So when a researcher reports correlations for more than two variables measured in a study, we have to use correlational matrices, right? And it's efficient reporting and interpretation, okay? So again, correlation matrix, looking at things like the GPA versus the mass, left grip force, and right grip force. So again, this is showing you the data table and the correlational matrix between the different parameters that we're studying in this. Okay, and then you see the little mini A's shows that something had a significance of a 0.05 level, right? So if you look at where the left grip force equals out to the mass, and the right grip force equals out to the mass, and the left grip force tables, those all have the little A's, right? So those were all statistically significant data points. Okay? Regression are statistical methods based on correlation that allows the prediction of one variable from another. The greater the strength of association, the better the prediction. So regression is going to be y equals k plus bx, where y is the variable to be predicted, a is the intercept on the y-axis, b is the slope of regression, and x is the value of the measured variable. Okay. Multiple regressions create an equation that uses more than one variable to predict the outcome variables. So you take two or more variables, determine which are most highly correlated, and using the equation. And the resultant correlation coefficient is going to be capital R. Okay. All right. Chapter. Again, we're not going to dive too deep into this stuff, and this is an intro class. If you guys go on to a master's program, you guys will dive more into these things. But if you guys have any questions or you want me to explain further, please email me, text me, let me know, and we will go over those in greater detail, make sure you understand what the different statistics and within. Okay? All right. See you guys in the next chapter.